Hello, friends. Good evening once again. I welcome you to another episode of Manthan. Manthan is a platform where we try to propose an alternate model of universe based on spacity instead of a classical model of universe where the gravity rules the roost. So we supplanted gravity with spacity and applied it to almost all the systems of the universe or the cosmos, like uh, Earth and Moon, solar system and its planets, Milky Way and its stars, black holes, various systems of the cosmos. In the same series, we took up a series of interesting questions based on the unexplained mysteries of the cosmos, and we tried to unravel those mysteries, and we did come up with quite a few interesting concepts to explain those mysteries. In the same series of these questions, today also we have another interesting question, bit off track, bit deviation from our usual concentration on cosmos. It's much closer home, planet Earth. But if you consider planet Earth as a part of cosmos itself, then we are not much off track. The today's question, interesting question, is about tectonic plate movement. And can they be exploited? These tectonic plate movements can be exploited for furthering prosperity of a nation. So obviously, one may think that when we are talking about tectonic plate movement, the nation's prosperity, exploitation, obviously one may think, possibly exploiting the energy that is released during the earthquake. No, we are not doing anything like that, but there for sure is exploitation, but exploitation of something different, exploitation of the river flow systems. It may look mundane, but it is anything but that. The river flow systems that we take for granted now, that we look upon it on our land masses, we think them to be permanent in nature, but they are anything but permanent. The reverse flow systems, as we see through these discussions, they change so drastically, in the sense, if the rivers were flowing now, let's say eastwards, once upon a time, the same river flow systems on the same landmass would be flowing westwards, which is exactly 180-degree change of difference. So we are now going to discuss how these river flow systems change and how they are connected, affected by the tectonic plate movements. And these ancient river flow systems, as we go through the discussions, you will see that these river flow systems leave permanent scars on the landmass that they are flowing. And we are going to see if those ancient river flow systems can be exploited to further a nation's prosperity. But it's going to be a very challenging subject, so we will have to go through point by point. Before we jump to the river flow systems, we need to understand a few concepts about tectonic plate movements. So, what is a tectonic plate movement? Every planet started as a ball of fire, and obviously over millions of billions of years, this planet cools down. And the cooling down is always from outside to inside. The outside, the terra firma that we all reside on, live on, is called as crust. And as you go inside, you have a hot solid core. The crust is cool, that is why we are able to live on it. And the hot solid core is obviously very, very hot. In between the center and the periphery, what we have is a various types of geological features. They could be hot molten magma in liquid form, and semi-molten rocks, and then the crust itself. These layers are not very well defined, in the sense you cannot say where one ends and where another starts. But for sure, they are different in nature. And hence, they are loosely bound to each other. So we have a crust on which we are uh, living on, and the crust that we see, generally they are represented by the various boundaries of the continent. But the crust does not end there. In fact, it goes beyond into the ocean floor. And generally, we may feel that these crusts are, how should we say, is continuous in nature, but it is anything but continuous. This crust is very fractious. It has got a lot of fractures. Possibly when the cooling happened, the solid crust kind of contracted and these cracks developed, or possibly because you have a molten magma which is moving slowly, but moving very, very powerfully. And since there is a loose connection between the internal parts of the planet and the crust, obviously there is a resistance to movement. And this may lead to the cracking of the crust. And the various, so hence the total part of the crust is divided into various plates. And each of these plate is known as tectonic plate. And this is what tectonic plates are. And the next thing that we need to understand is that these tectonic plates, they are always in motion because of the movement of the molten magma. Obviously, the crusts also have to follow that. And the next concept that we need to understand is continental drift. When the geologists or the scientists took a look at the world map itself, and when they saw the boundaries of the continent, they seemed to be eerily matching with each other, like a jigsaw puzzle. For example, the coast of Africa and south coast of America, they seem to be matching as though they were once a part of the single continent. And when you rearrange the various continents, like South America, Africa, Indian subcontinent, the Middle East that we know of, Antarctica, and Australia, they seem to be, the continents' boundaries seem to be matching like a jigsaw puzzle. And generally, it was felt that maybe all these continents were a part of a single continent once upon a time, and they broke and drifted apart. But it was a little difficult to prove. But as and when they gathered evidences like the geological features of the boundaries, these boundaries are thousands of kilometers away. But if you go and match the geological features, they were mirror image of each other. And that cannot be possible unless these continents were once part, they were a part of a single continent. Not just the geological features, the flora, fauna, there is no way these could be the same on either side of the continents, which are thousands of kilometers away. Even the fossils of the extinct species were also matching. So it was more than given that these continents were part of a single continent, and they broke apart and they drifted apart. And this is what is known as continental drift. And this part of the continent, which as we see here, is called as Gondwana. This was when it broke, let's say around 180 million years ago. India plate moved away towards Eurasian plate, South America moved westwards, Africa moved northwards, Antarctica moved southwards, and of course Australia also southeastwards. So the timeline that you can see here is when the India plate moved from broke from Gondwana 180 million years ago. It took around 130 million years to traverse this from this point to coming and hitting the Eurasian plate. And that is when the Himalayan mountains started forming. We will discuss about that a little later. It is not just about Gondwana breaking. These continent plates are not just breaking once. This breaking and joining has been going on for time immemorial. So even before Gondwana was connected to North America and the Eurasian plate, and that continent was called a supercontinent known as Pangaea. This was even before 335 million years ago. And even before that, when you go back in time, in Hadean times, as far back as 4 billion years ago, those were the times when Indian plate crashed into Antarctica plate of Antarctica. And this is another timeline that is important for us when we are talking about river flow systems changing. Now,